Hey everyone, here it's Andrea, and in this video we're going to talk about the different numerical systems that can be used within Python, and more specifically we will talk about the different built-in functions that Python provides for converting from one numerical systems to the other. Well, as you may already know, the most widely used numerical system is the decimal numerical system, which is basically the numerical system that we use in our ordinary life. And as the name suggests, it is based on 10 different digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, from which we can then obtain all the other numbers, all the possible numbers actually. However, in most computer-based systems, there is not only the decimal system that is used, and depending on the application, we can have different numerical systems. Like for example, the binary system, which is based on two basic digits, 1 and 0. The octal numerical system, which has 8 basic digits, and the hexadecimal numerical system, which is based again on 16 basic digits. As you will see, Python provides really some function that makes really easy the task of converting from one to the other. So we could just start now and see how this function actually works. The first numerical system that we will approach, of course, I assume that you already know the decimal systems. You will probably have been using it for your entire life. So I'm first approaching the binary system. As I already told you, the binary system is based on two basic digits, which are 1 and 0, and it's the system upon which all the computer-based systems are built up. And because basically 1 and 0 represents the on and off signals from which you can basically build all the programs and all the stuffs of the electronic related stuffs that are in use nowadays. If you're interested in how the binary system works, or how the conversion between a decimal system to the binary system works, I can give you a brief example here. For example, let's take the binary number 1, 1, 0, 1, and 1. So this is a binary number, and to see to which number in the decimal system it corresponds to, we have to basically make this conversion. So we basically start by assigning a power to each of these positions. So as I told you, we have 0, 1, 2, 3, and 4, and since the binary system is based on two basic digits, the base for the powers will be 2. So this means that basically we'll have these numbers at play: 2 to the power of 4, 2 to the power of 3, 2 to the power of 1, to the power of 2, 2 to the power of 1, and 2 to the power of 0. Hope you can understand my writing. Perfect. So now that we have written down these digits, for making the conversion, we just have to basically sum these numbers, and each of them will be firstly multiplied by the corresponding binary number. So let's make the conversion. So we will have 1 times 2 to the power of 4 plus again 1 times 2 to the power of 3 plus this time is 0 times 2 to the power of 2 plus 1 times 2 to the power of 1. Sorry, this is terrible. Okay, plus 1 again times 2 to the power of 0. So if we do the summation, we have that 2 to the power of 4 is 16. 16 times 1 is 16. Plus 2 to the power of 3 is 8 times 1 is 8. 0 times 2 to the power of 2 would be 4 times 0, so 0. And here is 2 to the power of 1, which is 2 times 1 is 2. And then 2 to the power of 0, sorry, I can just... 2 to the power of 0 is 1 times 1 is 1. So the total will be 16 times 8, plus 8 plus 2 plus 1. So we have 26 plus 1, 27. And this is the number expressed in the decimal system. So back to the code. If we want to do it in Python, it will be extremely easy. We can just take another number. For example, let's call it num equal, let's take 10. So 1 and 0 in the decimal system represents 10. But if you want to express a binary number, you have to use a prefix. It's like for telling to Python that you're actually writing a binary number. And so I can just type num underscore bin, which stands for binary. And the prefix that is used by Python to identify the binary numbers is 0b. And then we can type 10. To see the difference actually in these two different notations, I can print the two results. So num, the first one will be in the decimal system, while the other one will be in the binary system. Let's see. As you can see, 10 in the decimal system is 10, while 10 with the binary prefix means 2, because 10 in the binary system is equal to 2 in a decimal system. So perfect. Now that we know how to express a binary number in Python, we can see how to convert from binary to decimal, and of course vice versa. So let's see binary to decimal conversion. So let's start. So bin to des equal, and the function that is used is the function called int, and we just pass as input parameter the binary number expressed with the prefix, so 0b10, and then we can print it. So bin to des, and you can see that is 2. Okay, we can also do the opposite. So from a decimal number, we can get the binary number, the equivalent in the binary system. So decimal to binary conversion, and we have des to bin equal, and the function in this case is bin, which stands for binary, and let's pass this number 2234, so 2234. Let's see how it looks in the binary notation. So this to bin, and here it is. This number is the equivalent in the binary notation of 2234. As you can see, the first two digits are indicating that this is a binary number, so the actual number is this one. Sorry, this one here. Perfect. We can now move on to the next numerical system that I told you before, which is the octal system. The octal system, as the name suggests, is based on 8 digits from 0 to 7. And again, the conversion using Python, it's really easy. Let's see how we can perform the decimal to octal conversion. So this to oct. The function that is used in this case is called oct. And let's take a random number like 57 and see how it looks like. So print this to oct. And we have again the prefix, which in this case for the octal notation is 0, which identifies an octal number, and then 71. 71 is the expression for 57 in the octal system. To do the opposite, we can use again the same function as before, which is int. So let's say octal to decimal conversion, and we have oct to this equal, the function is int, and we have to insert the number with the only thing that we have to do is to remember the prefix, so 071, and we can print the answer. So oct to this, and it's again 57 as we did before. Perfect. Now we can also convert between the other numerical systems, so between, like, let's say binary to octal and so on. To this purpose, let me just show you these. So let's try to convert binary to octal conversion. To do that, let's start with this number. I can just type the conversion. So again, the function is always the same, so oct, and we have to pass in a binary number. So first thing to do, the prefix 0b, and then let's go with this number. This number, of course, is taken from the article that I wrote and that you can find on the website, on the Finxter blog, sorry. So yeah, it should be correct. Let me just print it. So bin to oct. Let's see if I get it. Perfect. And it's 4272. If you want to check it, you can check it personally and manually with the strategy that I showed you before on the blackboard. Okay. Now another thing that I wanted to show you is how Python represents the numbers in the different notation and how it stores their values. Because, for example, if we now want to again perform, let's say if we now have this number, which is in the octal notation, And then we want to convert this number here into oct, which is this one, directly into the decimal notation without having to write manually the its value. So as I told you before, we could go simply by so let's type again octal to decimal. So oct to des equal, we can type again the function int and pass as input bin to oct. Okay, and as you will see, this method won't work. It gives an error, and this is because basically the results, let me just run it again. This result, this variable that we are passing in this function is a string, and this function int accepts as input just integer numbers. Just numbers and not strings. So how can we solve this issue? Well, we can just type in the variable, and then we can also add another parameter so to specify the format of the variable. And by typing 8, we are specifying that basically this is a string that is representing an octal number. And as you will see now, we will get the answer, or I have also to print it. So oct to des, perfect, and it will work. Yeah, and we get our initial number that was 2234, the one that we used here. So, and if we were to do it for a binary number, we will have to specify 2, or if it was for an hexadecimal number that we will see in a couple of minutes, we will have to specify 16. So perfect. Now we're at the hexadecimal numbers. Hexadecimal numbers or the hexadecimal systems is based on 16 digits. So since we have just 9 different digits in our decimal system, we also use letter, which are A, B, C, D, E, F, and G, in order to arrive at 16. And yeah, basically the function and the working principle of also these functions is equal to the ones that I just showed you until now. The name of the function is hex. So let's just say hexadecimal conversion, and I'll show you all the possible cases. So let's see the decimal to the hexadecimal conversion. So text to hex, and the function is hex. Let's just pass the previous numbers, so 2234. Let's print it. So that's to hex, and this is the results. The prefix for the hexadecimal system is 0x this time. So this is the number, and as you can see, we have also the letters. Then we can also convert, let's see, from binary to hexadecimal. And let's type in the number that we used before, since we already know his value. And this is bin. Again, as you can see, same results because it's the same number that was passed in. Let's see finally the octal to hex notation, and the octal, it's the equivalent was this number here. Here again, the same number. Oh, yep. Sorry. Here, the 3 different way to convert from the 3 different numerical systems to the hexadecimal system. Perfect. To conclude, as you may have noticed, all the input parameters that I had to enter in all these functions are integer numbers. So you may wonder, what about the floating point numbers? Well, with floating numbers, it's a little bit more difficult because the representation of floating point numbers depends on the properties and the characteristics of different computing systems, and there are also different notations. However, Python provides a built-in function that allows you converting from floating point numbers in the hexadecimal system to hexadecimal system. And so let's see, floating point numbers. So as I told you, from the decimal system to the hexadecimal system. And this function is called float.hex. It's actually a method of the function float. So we basically can write float to, or basically float des to hex. And this is equal, as I told you, the function is float.hex. We can just type in a floating point number like this one, and we can print the result. So float to hex, and we should get the result. Here's the result. As you can see, it's quite different from the others. It still has the prefix of the hexadecimal notation, but then it is really different. And this is because basically Python uses the scientific notation for representing the hexadecimal floating numbers. And if you see in the article, I just wrote down the links for understanding better how this notation works. Basically, this P stands for times, so this whole number times 2 to the power of, and this is the exponent of the 2. This is the decimal point, this is the integer part, and so on. So if you're interested in the different notations and how to represent floating numbers, you just check in the article and you will have all the material that is needed. So for this video, I think it's all. Hope you liked it and hope you find it useful. See you in another one. Bye bye.